Hello students, have a very good day everyone. So now we will start with chapter 2, Alternator, and today's topic for discussion is Alternator principle. So today's contents are basic principle, speed and frequency of alternator, some of the terms common to armature windings. Here we are going to basic principle of alternator. Firstly, the working principle of an alternator is very much simple, and it is just like the basic principle of a DC generator. They also consist of armature winding and field winding. And listen, unlikely DC generators, here the field systems rotate and the armature is stationary. Listen very carefully students. In case of your DC generator, the armature was stationary, the field was rotating type. But in AC generator, the field system rotates and the armature is stationary. What is the reason? We have already discussed in the previous slides. Now, it also depends upon Faraday's law of electromagnetic induction, which says the current is induced in the conductor inside a magnetic field when there is a relative motion between conductor and the magnetic field. As all we know is alternator takes mechanical input and it provides electrical output, and it depends on Faraday's law of electromagnetic induction. According to this, when there is a relative motion between the conductor and the magnetic field, then current is induced inside the conductor and in the magnetic field. So, when the rotor rotates, the stator conductors are cut by the magnetic flux, and hence they have induced EMF produced in them. Listen, whenever the rotor rotates, the stator conductors, the armature conductors are cut by the magnetic flux, and as a result they have induced EMF produced inside them. Hence the poles induce an EMF and current in the armature conductors, which first flows in one direction and next in the other direction. Be very clear. The poles induce an EMF and current in the armature conductors, and this EMF flows in one direction, that is positive half cycle, and then in other direction for negative half cycle. So an alternating EMF is produced in the stator conductors, whose frequency depends on the number of north and south poles moving past a conductor in 1 second. The frequency of this EMF depends on the north and south poles moving past a conductor in 1 second, and also whose direction is given by Fleming's right hand rule. And the direction of this EMF is given by, let me tell you, Fleming's right hand rule. All of you might be remembering, according to Fleming's right hand rule, our thumb will represent the motion of the conductor, our index finger will indicate the magnetic field, and the middle finger will indicate the current direction. Accordingly, the direction of the EMF and current can be indicated. Now, speed and frequency of alternator. The synchronous speed is the speed of the revolution of magnetic field in the stator winding of a machine. It is the speed at which the electromotive force is produced by the alternating machine. So, the synchronous speed is the speed of the revolution of the magnetic field in the stator winding, and that is fixed for the machine. The frequency of the generated voltage always depends upon the number of field poles and on the speed at which the field poles are rotated. Next, one complete cycle of voltage is generated in an armature coil when a pair of field poles passes over the coil. Note it down, students. One complete cycle of voltage is generated in an armature coil when a pair of field pole passes over the coil. One field pole passes, positive half cycle is produced. Another field pole passes, negative half cycle is produced. As a result, after passing of a pair of field poles, we can see a complete sine wave. Let P be the total number of field poles, capital P, and small p is the pair of field poles. See, this is the total number of field, this is the pair of field. Okay, if capital P will be 4, small p will be 4 by 2, that is P. 2. Capital N is the speed of the field in revolution per minute. Small n is the speed of the field poles in revolution per second, that is RPS. And small f is the frequency of the generated voltage in hertz. So, we know synchronous speed is 120 f by p. If we will take small n, it is n by 60, that is RPS, and we know capital P by 2 is your small p. So now, in one complete revolution of the rotor, the armature coil is cut by capital P by 2 north poles and capital P by 2 south poles, or we can say it is cut by 2 poles. One pair of pole भी बोल सकते हैं और 2 number of poles. Since one cycle is generated in an armature coil when a pair of field poles passes over the coil. So now, let number of cycles per revolution is small p. Number of revolutions per second is small n. Now, the frequency will be, frequency equals number of cycles per second. That becomes number of cycles per revolution into revolutions per second. Or we can write frequency equals small p into small n. Again, we know small p is capital P by 2. Small n is capital N by 60. So, by putting all these values, we will get small f frequency equals capital P, capital N, and in the denominator 2 into 60, that becomes 120. We can say the above equation gives the relationship between the number of poles, speed, and the frequency. Thank you. Thank you, everyone.